So we're going to start with what's the definition of a composition. And the definition of a composition is that you substitute one function in for x in another function. I need you to think about that constantly throughout the whole lesson today. I am not multiplying functions. I am not adding functions. I am substituting a function in for x in another function. One of the hardest things that students will encounter the first time they do compositions is extra x's will show up that shouldn't be there. So a lot of times, instead of actually doing substitution, we make it more of like a multiplication problem, where we leave the original x and then we just like multiply by the other function. Okay. But what we have to keep in mind is that the function that we're plugging in is going to totally replace the x that was originally in the function. Okay, so we're kicking out one x and we're plugging a whole function in its place instead of a number. Okay. Now, there is a new notation that goes along with this, since it's not addition, subtraction, multiplication, or division. It just looks like function notation with a lot of parentheses. Okay, so it has two sets of parentheses there. And when I read that like I would read a function notation. So I'm going to write in quotes how I say this. This is f of g of x. Remember when we saw the old function notation, just f of x? That's all we had to say. This is Miss Cronky. She's on plan. Do you want me to check if she's in the science office? It's third hour. Oh, okay. Well, good luck on your search. Bye. It's weird to take a phone call with 23 people staring at you. You want to know what happened? Okay,
Sure.
the secretary was looking for Mrs. Ingerson because she's looking for a student in second hour, but she really needs, it's third hour, so she needs to call a totally different teacher because now the student is in a totally different class. So no worries. Okay. Cool. Can we go back to learning? Yeah. Okay, great. Kylie, why are you always laughing at me? Can't take it. Not again. Okay. F of g of x. Now, what does that mean? That means we're going to actually take the g function, whatever that is. So, like, you have a function called g of x, right? G of x equals x. Who cares? You're going to plug that in to the x in f. Okay, so this means plug g of x in for x in f of x. So remember, you're not adding functions, you're not subtracting, you're not multiplying, you're not dividing. You are substituting. So that notation is going to tell you which function to substitute into which other function. There's no mathematics over there, so that's like always like the left side of your problem. And remember, it's really just a fancy way to write another y. It's just saying a new function that is the composition of the two functions. Okay, so it doesn't mean anything mathematically other than to tell us what to do. So I'm going to give you two functions, and we're going to do some function compositions. But if you could just real quickly write these two functions down. They're similar to the ones that we did yesterday, but I think g of x, I have a sign change there. We're going to let f of x be 3x plus 5. We're going to let g of x be x squared plus 1. And we're going to try some different compositions. So we'll say perform the indicated operation and of course state the domain. We're going to do the same thing that we did yesterday. I will say most of the time your domains will be all real numbers. Big issues are going to happen if you have a division, if you see something that looks like a fraction, or if you have a square root, okay, or another even root. That would be maybe time for pause to really check over your domain. Okay. Let's do f of g of x first. So that same notation I gave you on the last slide. Let's do f of g of x. This means we're going to take g of x, and we are going to plug it in for x in f of x. What is g of x? Okay, it says x squared plus 1. Would you be okay with me saying, since g of x really is x squared plus 1, can I write this? Oh, and I have this extra parenthesis that shouldn't be there. Sorry. I forgot to erase that. That's not really there. Can I rewrite this as f of x squared plus 1? Are you okay with me substituting that into the function notation? It's saying do f of g of x, but you know g of x is really just x squared plus 1. So do f of x squared plus 1. Now, to write out what f of x squared plus 1 is, you would start with the function f. That's your outside function. So what does f start with? Starts with 3, correct? Okay. So I'm going to say f is 3 times x, but I don't want to write x. I'm going to kick out this x and put in x squared plus 1. And then I'm going to finish out the rest of the equation, plus 5. So when I get to this point right here, and I've like replaced the g of x with x squared plus 1, okay, I'm concentrating up here at this f of x with the 3x plus 5. The only thing that I need to change is that everywhere I see x's in f of x, I'm going to replace them with x squareds plus 1. Okay, so I'm kicking out those old x's, and I'm just writing x squared plus 1, which is g of x. So I'm substituting that in. For the 3 times the quantity x squared plus 1 plus 5, what could you do to simplify that? David?
You can multiply through.
Yeah, you can multiply through. That's called distribution. So you could distribute your 3 right here, and you would get 3x squared plus 3 plus 5. And then combine like terms, so then you get 3x squared plus 8. Now, look at the domain here. What do you think the domain is of this function? Are there any rules about dividing or square rooting that I need to be worried about? No, I've got a square, which is different than a square root. So domain is x equals all real numbers. Now, I should mention that, like, to have a domain of x equals all real numbers, it means that my inside function here should have also had a domain of all real numbers. So domain of g of x up here is x equals all real numbers. And domain of f of x is x equals all real numbers. So then that can carry over. If there was a restriction on one of those, I might then also have a restriction in my composition. I'm going to change it up. Let's do g of f of x. So I can write any kind of letter grouping that I want and ask you to do different kinds of compositions. It's just going to say, like, instead of plugging g into f, let's plug f into g. Yeah. So I'm going to do the same thing. I'm going to take this f of x right there, and f of x is really 3x plus 5. So I'm going to write that out as g of 3x plus 5. Remember, this doesn't mean anything mathematically. This is just a way to write a y. This is saying, what is your function when you plug 3x plus 5 into g? Okay, a new y. And then what you do is you go to this function that's on the outside here, this g. G is x squared plus 1, but I don't want to write x squared. What do I want to put in for x? 3x plus 5. So g of x would normally be x squared, but now it's going to be 3x plus 5 squared, because I'm kicking out the x that was there, and I'm plugging in the function f of x, which is 3x plus 5. So all I did right there was substitute in for that x, and then I have to finish the rest of the equation. So there's a plus 1. Question?
Why everything equals one?
Because I'm really saying, like, I'm using a notation there where all of this means y, right? And then this is just me doing substitution. F of x really is 3x plus 5. So I just substituted that in, so this is really saying y. So on the other side, remember this says y equals 3x plus 5. This says y equals x squared plus 1. So after I do that little substitution where I decide what I'm going to plug in for x, everything else is like what the function is. And then you should have it written out as y equals something.
How do you know what it equals?
Because I'm going to this letter that's on the outside of the parenthesis, g, and I'm going to g and doing x squared plus 1, but instead of x, I'm doing 3x plus 5. So this to me right here says g of x. Are you okay with that? But x is 3x plus 5. So g of x is x squared plus 1, but x is 3x plus 5. So everywhere there was that x, I wrote 3x plus 5. Again, I'm just substituting all the x's with the other function. That's all I'm doing is substitution. Okay.
So then would you technically have to write that with the y?
No. I'm only writing that because sometimes to have the g of f of x, people look at that and they don't know what the heck that means. And then people start turning that into like a multiplication, a g times f. Where I want you to recognize that when you say g of f of x, that means g of 3x plus 5, because you're plugging 3x plus 5 in for f. Now, what could you do to simplify 3x plus 5 squared? What's that? Multiply it by itself. You'd have to FOIL that one out. Okay, so this one maybe requires a little bit more work right here. This is really 3x plus 5 times 3x plus 5. And then, of course, you would still have your plus 1. But then you could FOIL this out and combine your left terms to get your final answer. So I'd get something like 9x squared plus 15x plus 15x plus 25, and then the plus 1, and then combine like terms. So 9x squared plus 30x plus 26. By doing that composition, did the domain change from all real numbers, or are we still okay with all real numbers? Probably still okay, right? There's no new fraction, there's no square root or fourth root or sixth root, so we have no restriction to our domain, and our domain would be x equals all real numbers. Now, I'm not going to do the next composition right here. I'm going to change it, and I'm going to ask you a different question. So we've done some compositions with just the letter x, right? What if I asked you what f of g of 2 was? What if instead of having an x, I put in a number? And which one should I plug it into? Our first or our second one that we created? Yeah, that's the one that you have to. So, like, I agree with Bailey. So that's just saying, oh, hey, x is 2, right? So plug 2 in for x. But we've done two different compositions. We did f of g of x, and we did g of f of x. Which one do we want to plug it into? F of g of x, right? We want to follow the composition. So we would actually be using the top one, and we would do 3 times 2 squared plus 8. But you're right, just substitute that number in. I think you'll have better success in understanding the process if you do it with the letters first. So just, if it asks you on your homework to do f of g of 2, first do f of g of x. And then get it down so you have the least amount of x's you can, and then plug that number in. And we'll have 3 times 4 plus 8, so that's 20. I have an answer there. Okay, questions that I can answer about the composition? The hardest part about compositions is making sure that you've set it up correctly in terms of showing the substitution, totally replacing the x. So if you need assistance when we're working on